In the last notes we talked about ionic bonds being between a metal atom and a non-metal atom. In these notes we're going to talk about how to hook up a metal atom with a non-metal atom in the right ratio so they make a neutral compound. Alright, in these notes we're going to talk about a little review from last time. What are some characteristics of ionic compounds? So first, hopefully you remember that in an ionic compound, or in an ionic bond, metal atoms are going to lose their valence electrons to become positive ions, or what are called cations. And remember they lose all of their valence electrons. So if they have one valence electron, they will lose that one. If they have 3 valence electrons, they must lose all 3 in order to make a bond. Now the nonmetal atoms are going to gain electrons to become negative ions called anions. And remember, they have to gain as many electrons as it takes for them to get to the nearest noble gas to them. So if they have 7 valence electrons, they need to gain 1 more, okay, to get 8. That's basically the happy number is 8, just like the noble gases. If they have 6 valence electrons, they need to gain 2 more to get to the noble gas configuration of 8. And if they have 5 valence electrons, they need to gain 3 more in order to get to 8. You know, that noble gas configuration that makes everybody happy. So if metal atoms lose to become positive and non-metal atoms gain electrons to become negative, then we have that attraction between positive and negative ions that holds them together in that ionic bond. And so in order for them to balance the repulsion between positive and negative ions, they have to form what's called a crystal lattice. And remember, that's this structure down here. So that should look familiar, where all of the positive ones are surrounded by negative ions, and all of the negative ions are surrounded by positive ones, and the negative ones are far apart from each other. The positive ones are as far apart from each other as possible as well. So it kind of balances everything out in what's called a crystal lattice. Alright, now that we know how ionic bonds form, we're going to figure out how chemical formulas for ionic compounds work. So, to figure out how we hook up metals and nonmetals, you have to look at what's called the oxidation number, okay, which basically is the charge on the atom after it loses or gains valence electrons. Because the overall charge of the compound must be 0. So that means you have to cancel all the charges on the metal and nonmetal atoms in order to make a neutral compound. The easiest way to do this is to do what we call a crisscross of the oxidation numbers in the ions. Because when you crisscross them, you're going to cancel them out, basically, and so you will get the correct number ratio of metal atoms to nonmetal atoms to make a neutral compound. So let's see how this works. Alright, say we want to hook up magnesium, which is a metal atom right here, and chlorine, which is a nonmetal atom on the right-hand side of the periodic table, and we want to make a compound out of it. Well, we have to first look at the oxidation numbers. So magnesium is in group 2A, so that means he has 2 valence electrons. And for magnesium, because he's a metal, he's going to lose those 2 valence electrons to become a positive 2 charge. So we're going to put a little positive 2 up on the upper right-hand corner for magnesium. Now chlorine is over here in group 7, so that means he has 7 valence electrons, and he only needs to gain 1 more to get 8. Okay, so that means he is going to have a negative 1 charge. So we're going to put a negative 1 right by chlorine. Now what we do in order to figure out the correct ionic formula is that we take the numbers in the charge and we crisscross them. So that means we bring 1 down over here by magnesium and the 2 down by chlorine. And that gives us MgCl2. Now you might be wondering where that 1 went, right here down by magnesium. Well, just like in algebra, ones are invisible. For example, you don't have to put 1x minus 3 all the time, right? You can just put x minus 3. Same thing with ones in chemistry. If there's a 1, they're basically invisible and we don't have to write them. Every other number, though, we do need to write. So remember, in a formula, what this means is that we have one magnesium atom hooked up with 2 chlorine atoms. So that's what the numbers are referring to. And you need 2 chlorine atoms to hook up with 1 magnesium in order to cancel out the charges. Let's take a look at a second example. This example is lithium, which is a metal, over on the right-hand side right here, and oxygen, a nonmetal, lithium's on the left-hand side, okay, with the metals, and oxygen is on the right-hand side with the nonmetals. Okay, so lithium is in group 1, okay, right? So that means he will lose his 1 valence electron to become a positive 1 charge. And oxygen is in group 6. So that means he has 6 valence electrons and he needs 2 more, okay, to become like the noble gas nearest to him. So that means he's going to gain 2, become a negative 2 charge. So we're going to have lithium positive 1, oxygen negative 2. Now again, what we do is we crisscross. We take the 2 from oxygen, we put it down by lithium, put the 1 from lithium, put it down by oxygen. So what we end up with is Li2O. Alright, the more you do this practice, the more easier it's going to get. And so we're going to do just one more because there's one more little concept that I want to share with you. So this time we're going to hook up magnesium and oxygen. Alright, so again, if we look at our periodic table, we have a +2 for magnesium charge, and because oxygen has 6 valence electrons, he needs to gain 2 more, so he's going to have a negative 2. Now, we can see right away that a positive 2 and a negative 2 are going to cancel out. And so when we crisscross those numbers, we get Mg2O2. Okay, because they are the same number, we can get rid of them. It's like, least common multiple kind of thing. So we're just going to get rid of the 2's and just call it MgO. Okay, so that's how it works. That's only if you have the same exact numbers for the metal atom and the non-metal atom. You can cancel them out and just write the letters for the symbol. All right, a couple more things to finish off this question. First, remember, in ionic bonds, the number of electrons lost must equal the number of electrons gained. And so in order to not be confused about how we can figure that out, it's easiest just to crisscross the charge numbers. That will automatically give the ratio of metal atoms and non-metal atoms to make the number of electrons lost equal the number of electrons gained. So there's no second guessing, there's no really thinking about it. You just crisscross. Now, when you're writing a formula, you always write the metal atom first. Okay? Always write the metal atom first. And then you write the non-metal atom. All right, let's take a look at the third question. All right, now we know how to hook up metal and non-metal atoms to make ionic formulas. We're going to take a look at this third question, which is, what are polyatomic ions? Now, you may have remembered the word polyatomic ion from when I was talking about your elementary knowledge sheet that you had to print out at the beginning of the year and put in your glossary. On that sheet, on that first page on the left-hand side, there's a list of polyatomic ions which you'll have to memorize for a future quiz. So let's take a look at what these polyatomic ions are. So these polyatomic ions are ions that are made up of more than one atom. So basically what they are is a group of atoms with a charge. So let's take a look at 3 examples from our list. We have nitrate, which is NO3, and basically it is a nitrogen covalently bonded with 3 oxygen, and together they have a -1 charge. in the second one, it's called sulfate. Sulfate is a sulfur atom covalently bonded with 4 oxygen atoms to have a -2 charge. And our last one here is phosphate, which is a phosphorus atom hooked up with 4 oxygens to make a -3 charge. So let's take a look and see how we work with these polyatomic ions in ionic compound formulas. So it's not too tricky. When we work with polyatomic ions in ionic compounds, we're going to treat them just like a single nonmetal atom or an anion. We're going to crisscross the charges just like we would in a regular compound. However, what we're going to do is we never change the subscript. The subscript is this small number down here, these ones that I'm circling right now. These guys are called subscripts. They tell you the ratio of how many oxygens are hooked on to the nitrogen or the phosphorus atoms. So we never change those, but we can, when we crisscross, we're going to put the charge numbers, okay, outside of the parentheses. So one of the tricks is to always put polyatomic ions in parentheses. So whatever number we're crisscrossing will go outside of the parentheses. And so that represents an entire group. If we need multiple polyatomic ions to cancel a charge, that is what it's representing. So let's take a look and see how this works. Our first example is hooking up a sodium with a phosphate group. Now we know from our periodic table that sodium has a 1 valence electron that it's going to lose, so it becomes a +1 charge. And from our memory banks or our elementary knowledge sheet, we know that phosphate has a -3 charge. So what we do is we crisscross those charges. We're going to take the 3 from phosphate and put it down by sodium, and we're going to take the 1 from sodium and put it on the outside of the parentheses of the phosphate group. So what we end up with is Na3PO4. What that means is that we need 3 sodium atoms hooking up with 1 phosphate group in order to cancel out their charges. All right, the second example we're going to take a look at is hooking up magnesium and phosphate, okay, to make magnesium phosphate. So here, again, magnesium has 2 valence electrons. He's going to lose both of those to become a +2 charge, and phosphate has a -3 charge. So again, we crisscross the charges. We're going to put the 3 from phosphate down by magnesium, and the 2 from magnesium on the outside of the parentheses for phosphate. So what we end up with is Mg3, parentheses PO4, close your parentheses and put the 2 there. So what that means is that we need 3 magnesium atoms hooking up with 2 phosphate atoms to cancel their charges. All right, we've made it to our last question for these notes. How do I name ionic compounds? So we've talked about hooking up metal atoms and non-metal atoms together and figuring out the ratios by crisscrossing their oxidation numbers. Now we're going to figure out how these compounds are named. And there's 5 basic steps that I'm going to write out for you. All right, so here are all 5 rules. Now, it seems like a lot, but it's not too hard, with more practice that you get. So let's take a look at how they go. First, whenever you're naming things, just like whenever you write out formulas, you're always going to do the cation first. Okay, the metal atom first, then the anion second. Okay. Second rule, the cations just use their name. So you just look at the metal atom on the periodic table. If it says Mg, that's magnesium. You just use the name magnesium. Okay, so they use their name. Cations use their name. Anions, rule number 3, anions are going to use, again, their name, but you're just going to change the ending to IDE. So instead of oxygen, it's going to be oxide. Instead of iodine, it's going to be iodide. So you just change that ending and make it an IDE. Now the fourth one is the tricky one, okay, because we're working with those pesky transition metals. And I always say that transition metals screw everything up, including naming, okay? So we've seen lots of tricky stuff with transition metals. Just expect it every time we work with them. Transition metals have varying oxidation numbers. That's why we can't use our periodic table to figure out how many valence electrons they have, because it kind of depends on their mood. Okay, so because they have varying oxidation numbers, you have to uncrisscross your formula to get their charge. Once you have their charge, they're very picky. You need to put the charge in Roman numerals in parentheses behind their name. Can they be more high maintenance than that? Okay, so I'll go over some examples of these. We'll have lots of practice, but just keep in mind if it's a transition metal in the middle of their periodic table, they're going to be very picky on how they get named. All right, let's move on to the last one, number 5. So polyatomic ions in their hand, super easy. If there's a polyatomic ion in the compound, which you will know because there's more than 2 atoms in that compound, it's got to have a polyatomic ion in it, and you just use its name. So for example, like I said in the last slide, with sodium phosphate, PO4 is called phosphate, so you just use phosphate in the name. Okay, so it's, whatever phosphate, something nitrate, it's super easy. So they're very easy. All right, so in the next slide, we're going to take a look. We're going to use these rules in order to name certain compounds. So let's take a look how this works. All right, so let's take a look at our first example, NABR. If we're given the symbol NABR, we have to figure out what name that is. What compound are we talking about here? So again, we look at our notes and we say, okay, so we name the metal atom first, the cation first, and that's sodium. We look, or Na, I should say, I just gave it away. Na, and we look at our periodic table and we see that Na is called sodium, so we're going to write the name sodium. And then we know to put the nonmetal atom next, which is Br. We look on our periodic table and it says Br is bromine. So we're going to use the word bromine. We're just going to change it from bromine to bromide. So this compound is called sodium bromide. As easy as that. Okay, let's take a look at a next example. So here we have CaCl2. Okay, so again, we look at our cation first, our metal atom, and we say Ca. Oh, look, according to our periodic table, Ca is called calcium. So we're going to write the word calcium. And Cl is our nonmetal. All right, and so we take a look at our periodic table and we see that Cl is called chlorine. So what we do is we take chlorine and we just change the ending to IDE, and we call it chloride instead. So this compound is called sodium chloride. Now, in the name, we do not have to address the 2 here. Okay, we don't have to say calcium dichloride or calcium chloride 2, because whenever we're working with ionic compounds, we will always have to crisscross. So the numbers come into play only when we're writing out the formulas, not the names. All right, let's do a couple more examples. All right, next one is Mg3PO42. Okay, so we see here that we have more than more than 2 elements in this compound. So we have a magnesium, we have phosphorus, and we have oxygen. We know that because they're all capitalized. In our other 2 examples here, we only had 2 different elements. So for example, here we had N and Na, okay, and Br, 2 elements. CaCl, that's 2 elements. Here we have 3 elements. So we know that we're going to have a polyatomic ion, plus they're in parentheses. So when we're working with polyatomic ions, remember we just use the polyatomic ion name. So we're going to start again with our metal atom, which Mg is called magnesium. So we're going to write out magnesium. And PO4 is a polyatomic ion, right? So polyatomic ions are easy. They just keep their name, phosphate. So magnesium phosphate is this compound's name. As easy as that. Again, we do not have to address these numbers here because when we crisscross charges, that's where those numbers come from. All right, we're going to take a look at one last example with the pesky transition metal. All right, CuNO3 2. All right, so if we take a look, our metal atom on the periodic table is copper, but we see that copper is a transition metal. All right, so we put the name copper because all metals like to be called their name. However, remember those transition metals are very high maintenance. We need to do something else. We need to uncrisscross to figure out the charge on copper. So to uncrisscross, we take the bottom numbers and we just put them back where we would have crisscrossed from. So this 2 down here by NO3 is actually the charge on copper. And this invisible 1 that sits down here is actually the charge on phosphate. So we know here from our numbers that copper is a positive 2 charge. So remember, transition metals want their charges named with them. So we have to put them in Roman numerals. So Roman numeral 2 looks like this. 2 capital I's basically next to each other. In parentheses, behind their name, copper. So copper 2. And then luckily for us, those polyatomic ions are super easy. NO3 is called nitrate, so we just call him nitrate. So this guy is called copper 2 nitrate. So a little bit extra work for those transition metals, but the more you do it, the easier it'll become and less annoying. So anyway, so that's how we name different compounds. Now, that is the end of our notes for this, and so I will see you tomorrow for the activity for this lesson. However, first, I wanted to just say that I've noticed in class that some people either A, are not taking the notes and just copying from other people in class, or B, they're taking the notes but they're not listening to what I have to say. So they're not actually, really listening to everything that the notes has in store. They're basically just, pausing it when the screen gets full and then copying everything down and then going to the next slide and pausing it and copying everything down without actually listening. So here is what I'm going to do. I'm going to start doing. And those of you who actually listen to the notes all the way to the end will have this advantage. I'm going to give a couple of extra credit points. Not every time for notes, you'll have to listen, okay, as to, what's in store and which notes will have extra credit, but this is how it works. So tomorrow, when you come to class, if you have listened to all these notes and you have heard this extra credit part, you will come up to my desk, you will grab a little sticky note, you will put your name on it and the keyword phosphate. Okay, you will not say a word to anybody. If somebody asks you what you're doing, you'll say nothing. Okay, because obviously they don't know what it's all about, and so they don't deserve the extra credit because they did not do their homework. Okay, so again, tomorrow to earn a couple extra credit points, you can come up to my desk, grab a sticky note that will be sitting on my desk, write your name and the keyword phosphate, and then slyly just go back to your desk and do what you were doing. All right? Okay, we'll see you tomorrow.